Hello guys, welcome back to Abstronic Circuit tutorial. Now, let's talk about how the bistable mode working by using the same IC ne555 timer IC. You can see pin 2 connected in between the momentary switch and 1 kilo ohms resistor, and the opposite of the 1 kilo ohms resistor will be connected to the positive power supply, and there are two portions of the circuit, very interesting. So let me highlight the first portion of the circuit, and you can see the violet is highlighting. Now you can see the signal from the simulator storyboard, and that voltage dropping from 1 kilo ohms resistor, and this voltage will be injected to pin 2. So let's inject the voltage drop from the resistor to the negative input from pin 2 of the internal block diagram of the ne555 timer IC. The positive input of the comparator 1 is 1/3 of the VCC, which is 4 volt, and the negative input from pin 2 is 3 volt. So comparing the two input, 3 volt is greater than the positive input 4 volt, then the output of the comparator 1 will be logic low, and the output from Q of the flip-flop circuit will be logic high. So when the output is logic high, then the output from pin 3 will be logic low. And you can see the LED is not glowing from both output at pin 3. Now, let me press the momentary switch. So when I press the momentary switch, the 2N terminal will be shorted, and when it is shorted, then the voltage drop from the resistor will be 0 volt, and 0 volt injected to pin 2. Now let's see what happened to the circuit from the internal circuit block diagram of the ne555 timer IC. So let's inject from pin 2 by 0 volt, and the positive input is 4 volt greater than the negative input, which is 0 volt. Therefore, the output of the comparator 1 will be logic high. So when the output is logic high, then the output from Q of the flip-flop circuit will be logic low, and the output from pin 3 will be logic high. Now you can see the LED is glowing. Now let's go back to the circuit simulation and let's see if the output from pin 3 will be logic high. So let's click the momentary switch. Now you can see the voltage dropping from 12 volt to 0 volt. That causing the output of the comparator 1 will be logic high. So when the output is logic high, then the output from Q of the flip-flop circuit will be logic low, and the output from pin 3 will be logic high. Now you can see the LED is glowing. Now let's highlighting the second portion of the circuit, and you can see the violet is highlighting and the signal from the simulator is third board. Since pin 4 connected to third board, then the output is remain high. Now what happened when I press the momentary switch? When I press the momentary switch, again the two end terminal of the switch will be shorted, and when it is shorted, then the voltage drop from the resistor, which is third board, now become 0 volt because the grounded pulling the voltage drop from the resistor. So therefore, instead of third board, the voltage will be 0 volt and it will be injected to pin 4. And now the reset is logic low, so therefore the output from pin 3 will be logic low and the LED is cut off. And let's see if the output from pin 3 goes to logic low. Now let me press the momentary switch. Now you can see the voltage from the simulator from third board dropping to 0 volt, simply because the voltage dropping from 1 kilo ohms resistor, which is 12 volt, pulling by the ground, and now 0 volt injected to pin 4, causing the output from pin 3 goes to logic low and the LED is cut off. That is how the bistable mode working by using ne555 timer IC. So guys, don't forget to subscribe to my channel, like and share. Now, let's see from the actual circuit on my breadboard.